Hi there! Today's video is centered on the power supply unit of the Theremin V.2. This unit is totally different from the previous one and is also built on a PCB. As a matter of fact, all the units of the new Theremin will be built on separate PCBs to help isolate the units from each other from the perspective of radio waves radiation. Before going into the details of this project, please take a moment to subscribe to this channel and to click on the bell that will let you know when a new video comes out. It will also help a lot if you'll give me a thumbs up at the end of the video. Donations are also accepted, which will help to make a continuous flow of videos on this channel at a constant pace. You can make a one-time donation through PayPal, or you can make a monthly donation via Patreon.com. Links are provided below in the description of this video. And remember, even a $1 donation will help. For this version of the Theremin, I have chosen to use a dual 12 volts power supply. This will have more flexibility because it will allow me to use more sophisticated units, possibly using op-amps. The circuit is very basic. It uses a dual 14 volts transformer capable of providing 1.5 amps at its output. The AC current of the transformer is converted into a DC current through the usage of a bridge rectifier and the capacitors C1 and C2. Regulation to obtain the 12-volt DC is done through the ICs L7812 and L7912. And finally, at the output of the regulators, there is one further couple of capacitors, one electrolytic and one polyester, for each regulator. These are used to absorb any peak of current that could be taken from the load and to filter out any residual radio frequency. The dual output is provided through several connectors, so each unit can be powered with independent cables, thus increasing the decoupling among units. I also published an article on my blog site eleneasy.com to provide the details of the design and calculations for this circuit. Please refer to that if you want to know more. The link is provided in the description below. Because the circuit is mounted on a PCB, its assembly becomes very easy. First, components are positioned on their slots, and then they are soldered one by one. A couple of heat sinks attached to the AC regulators completes the assembly, increasing the heat dissipation on the regulators themselves. As a side note, I will provide all the files necessary to build the Theremin, schematics and Gerber files to generate the PCBs, as well as the list of components. As an alternative, to make things simple for you, I can also provide for a small fee ready-made PCBs and eventually also the components to make it easier for you to build your own Theremin using my design. If you are interested in that, please drop me a comment. If I get enough interest on that, I will prepare a webpage where you can go and buy the components and PCBs to build your own Theremin. Testing is done very easily attaching to the power supply output a DC load and an oscilloscope to visualize and measure the ripple at the input and the output of the regulators, and make sure that the ripple is within the requirements. Details of the ripple are also provided in the blog article I already mentioned. The testing is done separately for each of the two outputs, increasing the output current from 0 amp to 1.5 amps. Which is the maximum current that this power supply can provide. Thank you for following me to the end of this video. I hope you enjoyed the episode and that together we will have fun building the new enhanced version 2 of the Theremin. And please don't forget to give me a thumbs up and to subscribe to my channel if you haven't done that already. The subscription of course is free, and if you also click on the bell that appears after you subscribe, you will be automatically informed of any video that will appear in the future on this channel. See you soon on the next video, and as usual, happy experiments!